Thank you, everybody, for having me here. I greatly appreciate it. I want to start off by talking about a bit of a story outside of our industry. And through the latter half of the 20th century, especially the latter half of the 20th century, companies like Kodak were part of culture. Kodak was how you documented your life and shared your experiences with families and friends. In fact, Kodak Eastman was cameras and film, ultimately to the mass public. In 1973, you even had Paul Simon singing, "Mama, Don't Take My Kodachrome Away." The brand, their products, and their whole identity was directly tied to human experience. Now, ultimately, as many of you know, this is a cautionary tale for any industry that might miss the wave of innovation provided by digital transformation. A little bit of background on this. Steve Sasson started working for Kodak Eastman in 1973. He created the first digital camera in 1975, and it was patented by Kodak in 1978. 1989, they created the first digital SLR. We don't associate Kodak with digital technology or digital cameras right now, but they had the patent. Now, this is where things go wrong. Marketing told them not to put it out there because it would eat away in their film sales. And there was a constant battle between their core business model in film sales and what was ultimately the next generation of technology when it comes to film. So what happens? Others move into the digital camera business and paid Kodak patent royalties. And we all know what happened next. Smartphone era put a camera in everybody's pocket. Kodak wasn't going to survive just by owning a patent. And anyway, that patent expired in 2007. In 2012, Kodak filed for bankruptcy. Now, simply put, Kodak failed to see the transformation of the film industry that digital would provide and how it would change their products. And we'd see that sort of pattern occur again and again through the 1990s and early 2000s and 2010s. Now, over to our industry for a moment. We went through the first wave of digital transformation through probably the 80s and 90s and such when we were starting to look at a mere transformation of physical drawings into CAD environments, effectively just mapping what was always an analog process into a digital tool. Luckily, we've moved beyond that. In architecture specifically, our best work doesn't just superficially map an analog process onto digital environments. Instead, it starts to rethink the fundamentals of collaboration. It considers downstream processes for things like materials, fabrication, and even pre-fighting assembly. On the SAMRI project, this is referred to as the Stingray module. It was the most complicated piece in the entire structure in terms of curvature and the methods of fabrication and the detailing necessary to execute it. Our best work in the industry also considers the actual craft of fabrication so it can be most efficiently and accurately executed. Now, given this is still manual welding, it was done with laser sight checks, so arguably is digitally augmented fabrication. Our best work also considers on-site assembly processes. And using the methods provided by digital technologies, we can bring forward all these dimensions to help actually influence the design process itself from the earliest stages. A simple mapping of analog processes and digital tools never would have actually provided that. And ultimately, in the end, all this is in service of the final product itself, buildings and spaces that are built to serve a purpose, to provide a social and a functional space for the inhabitants, and ideally evoke delight in those who actually get a chance to experience them. By considering all steps in the life cycle of design and construction, it not only gives us the opportunity to mitigate some of the risks of building, but also bring about new approaches to craft, of form, and materials. And at Woods Bagot, we've witnessed leaps in how the construction industry has embraced digital processes, specifically here in Australia, even on projects like this one, which is just a short walk down the river from SAMRI. Now, I have a strong experimental streak in me. Rafiq asked me a question yesterday about a group that I'm involved in called Smart Geometry. Smart Geometry focuses on how we challenge next generation digitally enabled designers to move beyond the processes and tools that are presented to them by the software or construction or design industry itself. It very much is focused around this idea of active workshops around analysis and iterative prototyping. So what does it mean to start combining digital and physical processes together in a tight feedback loop? What happens when we start adding visual programming environments, analysis engines, physical actuators and sensors, and computer vision as a core part of our design iteration process? That is effectively looking at how we explore the next generation approaches to how we design itself. And ultimately, this is one of my roles within Woods Bagot, is to focus on transformation of the processes that we have and how we design and deliver projects. This is a favorite quote of mine from Elon Musk about the development of actually their batteries factories, and this idea of constantly evaluating the process at which you execute those factories. So the factory itself is the product. The factory is the machine that builds the machine. It actually deserves more attention from the creative and problem-solving engineers to produce than the product it makes. And this is basically how I live my life, and I think a lot of you kind of sit in that exact same territory, is what we can do to tune the engine, to add more capability to what we do from a process perspective to ultimately enable a better product in the end. So where I go with this is we're undergoing a transition from the pure digitizing of an analog process to something that's more inherently digital. It's a second major change in how we design, and I would argue it's a transition from static to dynamic, a dynamic integration of analysis, visualization, and production, all influencing design live. Now, for us at Woods Bagot, we start with people, the people who inhabit urban environments, and buildings, and spaces, and we aim to optimize not just for building performance, but ultimately for the human experience. To enable this, we build apps, and we build a lot of apps. Apps that help us visualize urban data to help clients select vibrant communities for their buildings. Everything from land use to subway distances, even Yelp ratings of the nearby coffee shops. We also build apps to explore all the various options in building massing, relating to zoning envelopes, views, shadows, solar analysis. In this one's case, this was an app that was shown live to a client during the process of design, and the last one was one shown live to a client. So we can work iteratively with clients back and forth at earliest stages, informed by data, both in the urban environment as well as the kind of data resident in the occupants and the people around, and put together interfaces like this to walk through and basically explain to them this is an informed way of design, even at the earliest stages of our work. We even build apps that automate blocking and stacking approaches, things that will maximize program and any other factors that might positively benefit occupant experience. And each of these can be custom to a particular client's program. And we build apps that help us ultimately understand the experience of each individual in the building, cognizant of human behavioral patterns. So moving from urban scale to district scale to building scale to floor scale to the scale of an individual person. Our design technology team builds apps to move beyond standard BIM methodologies and technologies, and the intent is to integrate analysis and production models and approaches to production into a live design feedback loop. We build custom apps to enable clients to experience our designs live from even the earliest stages. This is a simple workflow we developed using game engines to do a less than 1 day turnaround from a Revit model into a custom VR environment, distributed on the web that a client downloads just with the code. And they can install it directly on their phone and walk through their design as need be. And this is an area we're continuing to explore, which is how we ultimately combine VR experiential environments with analytic environments to have them exist in the same area. This was for a project that we did, an exploration for Canary Wharf in London, where we started to take the analysis engines that we got from our Superspace team that I showed earlier about circulation, about urban interactions and the data resident in the urban fabric, and start combining it with first-person views of the experience of the space, and even further than that, design exploration. So that no longer is a matter of applying static analysis to a static design, but instead an integrated dynamic environment. This enables our designers to actually work and explore in an informed space, live. All of this serves the purpose of automating parts of our process and augmenting others. And we take care in designing the design workflow itself. Some of our applications will focus on automation, trying to just remove some of the drudgery and busy work. I think it was yesterday mentioned, who wants to do door schedules anymore? That's an obvious one. But there's a lot of examples of automation, of processes that are standardized within the architecture and building practice that can be completely automated, which then frees us up a wealth of more time to explore things in the design process, to be creative, to use the intellectual parts of our mind to progress the design further. And that's where we start getting into the augmentation side of it. What does it mean now to have these tools available to you live to enable you, to move you into an augmented form of design? Now, significant effort has been made on better understanding adjacent and downstream workflows in design and delivery, and creating a working environment that best suits the needs of the project itself. Now, this is actually a design workflow for Christchurch Convention Center. This is a project mostly run out of a combination of our Melbourne and Adelaide studios, but also with our studios in New Zealand. So focusing on the kind of process to walk you through just a bit of it, initial Rhino geometry in terms of the design exploration process. There's obviously, as with anything, a model cleanup process, as well as a subdivision and planarization. So what does it mean to actually modify the surfaces that are generated to turn them into buildable geometry? You start adding additional parameters that might be associated with how the structure gets put together. You unroll it in order to generate the tiling patterns that are necessary that will ultimately then be re-rolled back onto the surface again. And then you also go through and you explore that 3D form generation and how it informs the design and document delivery process, so that information is then carried over to delivery platforms. And in terms of outputs, beyond just the model itself, you end up with all the standard 2D drawings you would typically expect, Excel data sheets, which gives the information necessary for each of these pattern panels, and then the renderings that are necessary from it as well, all part of a core process. Now, a lot of this stuff can be standardized. These are things that we repeat again and again, but there are absolutely parts of projects that require some custom attention to designing the design workflow itself. It allows us to think about designing robust and resilient delivery methods. So how do we work with receiving design concept and structural models and effectively restructuring them to automate things like panel generation and drawing production? And the point of this is to make it into a resilient system, not a one-off. Something where the methodology factors in the need for the fact that there's a need for constant change. And this project in particular that included weekly updates to structural design and even changes in form that had to still generate all the schedules, all the drawings and updates for the panels at that moment. I think it took something about 20 minutes to process it. This is almost a live stream. It also allows us to design a design workflow where geometry rationalization and even things like material limits, in this case, curved glass, but then even further into model quantification can be built into the process. We effectively design, analyze, and iterate in a tighter and tighter feedback cycle. And we benefit from the fact that most everything is quantified or quantifiable. Geometry, parameters, other metadata like material information or performance data. And the good thing is we can make it bend to our will. And we do that because it's quantifiable, we can control it. Now, this is Grasshopper. I'm kind of curious in the room, raise your hand, how many are familiar with what Grasshopper is? Okay, so I got maybe about 5 to 10% of you. So for the rest of you, it's a plug-in tool for the modeling tool called Rhino. They're all named after animals and insects, as is typical with this. It's one of the visual programming environments that we use to manipulate geometry and to analyze form and space, and ultimately to build control systems to manipulate design. It's made up, similar to tools like Dynamo and others. Grasshopper has existed since about 2010, 28, 29, somewhere around 2008, 2009 is when it started. It's effectively a collection of components, and those components can manipulate data and geometry in whatever method necessary. Those components could be modifications in data streams. It could be modifications in how it analyzes environmental analysis. All these things kind of pipe through each of these components and spit out an additional bit of data, and you chain this together to build workflows, live workflows that can be modified throughout the design process. Now, our industry is migrating from a file-based collaboration system to one that's data-driven, as data-based across multiple platforms. This is a diagram of geometry and data flows in a project based in our New York studio. And this one's specifically showing a combination of Rhino, Grasshopper, Flux, and Revit, all live streaming to each other. And we built this in to serve the needs of how the project needs to be designed and how the project needs to be delivered. So this is a diagram of project workflow and all the steps that are necessary. And it's not meant to be a static entity. It changes over time. But actually, the products are not meant to be static either. We're able to manipulate this and modify it as the design progresses over time. It allows us also to keep each platform as pure as possible for what it's suited for. That's the sort of interoperability approach we're trying to build into this workflow. And that allows us to make them bend to our will in the service of those design and delivery methodologies. Now, this requires a new kind of expertise in our practice. This was mentioned a little bit yesterday by Doug and a few others. In a few cases, this has been referred to as the new architect-developer class of people. These are people where a tool like Visual Studio is as frequently on their screen as a modeling environment. And this enables you to have a rapid generation of not just project-specific workflows, but also redeployable apps that can be utilized across the company. This, for example, is our building performance app. It creates an easy interface on top of what is sometimes considered arcane analysis systems. It enables the average designer in the company to access a wealth of information regarding climate and building performance, all live, without needing to even know visual programming tools. We've also gone so far as to actually release some of these tools publicly for use. In this case, this is tools for Grasshopper and Dynamo. And in the tradition of naming tools like this after animals, we had to pick a distinctly Australian animal. So go look it up, Grasshopper and Dynamo. They're available online. You can download them and give it a go. Now, recently, our design technology team had the opportunity to partner with one of our project teams in the design and delivery of a large project. This project, for me, exemplifies what happens when you craft a design and delivery strategy integrating data flows, design workflows, and even delivery requirements. And we have multiple members of our team come from Melbourne, come from New York, and other places around the globe to go help that particular project to invent a new way of working. One of the methods that we worked was to build project-specific applications to adjust form in the context of the design intent and the requirements. So again, this sits on top of one of those visual programming environments, but also allows people who are not familiar with that environment to control the system in a simple user interface and manipulate the geometry of the design however it needed to be done, and also trigger downstream workflows, whether that was pushing data into Revit, whether it was getting Excel spreadsheets, whether that was exporting PDFs and Adobe Illustrator files for presentation graphics. All that was built into the system, and all that was built on top of a robust approach to how we think about the building performs and the data associated with that building. And this is an app that it allows us to connect with basic performance information, verifiably giving the client confidence that we're meeting our program requirements even at the earliest stages of design. It's an app that can integrate structural exploration. Take a look at the effect on form and program that it might have. Send the data streaming to Revit and early stage delivery documents. And all of this information is live, informing design as it progresses, and driving all the data and drawings that the clients ultimately need. So we had the opportunity, as with the VR work, and as with some of the site analysis for urban design that I showed earlier, we had the opportunity to just demonstrate this workflow live in front of the client. Absolutely amazed with the sort of things we're able to do with this, and able to give them the confidence that our workflow was not just a standard one based upon what the industry is doing, but a step or two higher based upon what they need as an individual client for their particular project. The point I'm trying to make here is that the second phase of digital transformation and design allows us to go from a pure optimization instead to an informed and augmented kind of agency in design. Ultimately, software opens the door for hybrid models of computer and human agency in design and delivery. So in the end, this has to service the architecture itself. And to fully flesh out this idea, I'm going to walk you through the Wynyard Walk project in Sydney. So from the earliest stages of the design process, there was immediate attention to form, to materials, and the opportunities that could be provided through digital fabrication. This was one of our projects that benefited from a strong engagement of our design and technical leads who were cognizant of the opportunities provided by digital processes. It included a tight connection working across scales, starting with the design intent focused on pedestrian experience and people flow. And models were shared between our New York and Sydney studios on a daily basis, reviewed over a video conference. Any of you know Woods Bagot, we have a really strong and kind of pervasive video conference culture. And sadly, being in New York, that means I'm on 1 a.m. and 3 a.m. video conferences all the time. The thing about this project is we went even so far as to modeling how this experience in space can be best realized in materials assembly. So again, different scales of modeling. And then mock-ups were built to explore the final material form and finish and the assembly process itself, which that information made its way back into the assembly and fabrication models. And in each case, we picked the right tool for the job and made them work with each other how we wanted them to work with each other. And the result was an interoperability workflow between Rhino, Grasshopper, and Revit, with Rhino and Grasshopper providing fluid concept design environment and the ability to kind of execute complex geometries, and Revit providing the full model coordination and documentation. And all of this material was able to serve purposes downstream as well. The model handover went over to our digital coordinators at ARMA, based in Sydney, and the fabricator Ashurco, who did the GRC, which is the glass reinforced concrete panels that you see on the sides and kind of executed here. And they took those models for further development and digital fabrication. And this, again, is in service to the product itself, the actual architecture. I was lucky enough to get a chance to see this literally the first day it opened. Now, granted, it wasn't the same experience because pedestrians weren't walking through it at the speed they typically would. It was a lot of stopping and photographing. And as a New Yorker, when people stop and photograph, that drives me nuts. But it was a good experience to actually see the space for a project that I had seen start to generate and really come to fruition in digital form to ultimately make it into everything in terms of the actual details and the shapings and the intersections between materials. But the digital process itself, digital processes didn't just affect the design process or even the digitally fabricated product, which is the precast panels. It also affected how we design the space itself and the focus on pedestrian experience. Now, I do highly recommend, I didn't get a chance to see the digital art when it was up, but I do recommend if you get a chance to pass through here someday, that you get a chance to see that digital art piece that's shown here. And for me, this art piece signals what I would kind of call as a third shift in how digital technologies will affect the architecture profession. And that is the ways in which we, as human beings, experience space itself. Now, I'm going to park that topic for a moment, and I'm going to come back to it in just a bit. To just kind of summarize what I've been talking about for just a bit here, I have been discussing the digitization of the design process and architecture, how a necessary second phase of that digital process moved us away from mere replication of analog processes to something that's inherently data-driven, and to get to this idea of moving from optimization to an informed and augmented agency. But I have to admit, I'm still worried about our industry. So I'm going to come back to Kodak for a second. For Kodak, the mere digitizing of an analog experience, that experience being taking photographs and printing them, did not save them. What they failed to do, what they failed to understand, is what their product was and what their business model needed to be that enabled them to deliver their product. What was Kodak's product? Kodak's product was the experience of documenting life and sharing it with family and friends. They were in the experience economy and they didn't even realize it. The ways at which we document and share our lives, our experiences and others is no longer printed on photographs and hung on walls in physical albums. In order for Kodak to survive, they needed to become Instagram. So that starts asking me, what is our product in terms of the building industry? What are we close to? What are we good at? And how does that actually affect our business model in order to enable those kinds of things? And to help tease this out, I'm going to talk about what I would say is some of the single biggest influences on that product itself. The first one is the dematerialization of computation. So if you look at this diagram, on the Y direction is the sort of pervasiveness, the way at which computing is just distributed through every parts of society. The X direction is time. So 1960, information technology is born. That's the mainframe computer. 1970, computers begin to communicate with each other, the network. 1990, the emergence of mobility. 2000, 2005, systems start becoming ubiquitous. And 2005 to 2010, we have the beginnings of intelligent systems becoming ambient within the space itself. 13 billion internet-connected devices in 2013, projected to be around 50 billion by the time we get to 2020. And this type of thing will have a greater impact on the experience of the built environment than our architectural designs. Mark Weiser, who's the chief scientist at Xerox PARC, started talking about, in his work and early thought leadership around ubiquitous computing and ambient intelligence, stated, the most profound technologies are those that disappear. They weave themselves into the fabric of everyday life until they become indistinguishable from it. I don't want screens everywhere. This would drive me absolutely nuts. This is the sort of, and I also don't want this kind of perfect future with maximum productivity and zero waste of time. I like wasting time sometimes, at least in my personal life. That's totally fine. You know, Malcolm McCullough in his book, Ambient Commons, said, does having more ambient information make you notice the world more or less? Or does it just lower the resolution of life? This is where I start thinking about the principles of HCI, or human-computer interaction. One, the purpose of a computer is to help you do something else. Number two, the best computer is a quiet, invisible servant. Number three, the more you can do by intuition, the smarter you are. The computer should extend your unconscious. And a lot of what I talked about in the first half is very much in that category. Number four, technology should create calm. Do you feel calm with your technology? This is where I start thinking about what it means to return people to the center of this process. It's ultimately thinking about a phenomenological approach to how we design and how we integrate technology in the work that we do. Ambient intelligence is all about how computing dematerializes, how it integrates into space. So if the first dimension was about the digitizing of space, the second is digitizing ourselves. So this is thinking about the impact of personal assistants like Siri and Google Now and Cortana. This is where we start thinking about what it means to be a hybrid between our physical and digital selves. And we exist in that constant hybrid now. I've got my watch on, my phone I shut off so that nobody calls me on my watch. But we have multiple pieces of technology on us at any time, and that basically means we exist in multiple personas at any time. We measure ourselves. We measure our performance. Topics like the quantified self. Again, I've got my Apple Watch on that's been trying to see when I complete my rings through the course of the day. And we measure our dogs too. On top of all this though, we have artificial intelligence and machine learning. So we look at what data we can get from the digitizing of spaces and ourselves. We better understand it, we make predictions, and we act on it. The combination of all of these will have a greater impact on the experience of space and on our lives than anything a traditional architect can do, even more than how we digitize our design and delivery process. That, for me, is the real existential crisis of our profession. The building is not a static thing made of concrete, steel, and glass, but it can be dynamic. It can be a computer in and of itself, able to learn and optimize human experience. And this is where I start thinking about this transition from the design of artifacts, a physical static building, but instead to a learning system itself. There's many ways that this can be done. You can integrate digital displays with sensors to interact with passengers. This, again, back to the Wynyard Walk project that I showed earlier. There's people who are exploring playful, adaptive environments that can read movement and such. In this one's case, not necessarily performative, but maybe kind of fun. Other ones that can be performative, this is actually work done at one of the Smart Geometry conferences on a ceiling that changes its shape to affect the acoustic qualities below it. So what does it mean then when the requirements of space change to become one that's for presentation purposes to one that needs to be a private meeting chatting over a coffee? Now this starts to get a little bit crazy after a while. You start thinking about not just physical transformations of space, but virtual integrations of augmented reality and mixed reality. Now we have benefited from artists exploring the drawbacks of augmented reality, the ideas of constant distractions and advertisements. I personally don't want to be walking through my day and get a notification, your afternoon is being brought to you by Whole Foods, click here to buy some avocados. But augmented reality is happening now. This is Disney, and this is their Magic Band. And the Magic Band is specifically tuned to the people that are wearing it so that the children and the parents, when they show up, can have a custom experience specifically to them, even down to the process of walking into a room and having a digital avatar greet them by their name, knowing their favorite food or whatever kind of information that you've provided to it. That is an augmented reality experience, and all it requires is that band for them to know where the person is. Now, there's a fascination in architecture with adaptive buildings. I've shown you some examples of things kind of moving around. Some of it's just art installations and such that don't actually require sensors or actuators, but just move through space. Other ones actually do have motors to control them, this being a project by ADIS. Although in this one's case, it doesn't actually have any sensors. It's recorded in advance and simply plays it back over time. You just press play. There are, however, many kinds of examples of smaller scale installations like this that actually have proper sensor environments. Now, I think to a certain degree, it's important for us as an industry to be balancing our approach to active solutions to those that are more static and passive to create dynamic environments. A passive solution can still create dynamism. So ultimately, you got to put your money and your energy where it's going to be most effective, and don't forget things like vernacular solutions. But there's also low and high-tech hybrids. So this is Enrique Ruigel's project called MediaTek in Barcelona. And what's interesting about this one is this is an ETFE facade, so an inflated facade. And there's some low-cost sensors that are put inside this to detect the overall heat gain coming through the sun that's going through the surface there. And what it does is when it passes a certain threshold, it starts pumping nitrogen into those ETFE panels, which then makes them translucent and starting to reflect the sun in a different way. And what's interesting about this is that when companies like Intel and others came in and said, we're going to provide you a solution for this, it was in the $10 to $15 to $20 million range for the project. They've turned around and started installing Arduinos. $20, $30, $40 units with a bunch of other pieces attached to them for a significantly lower cost. So arguably high tech, but low cost at the same time. Where this starts to point me is a next generation building management system. We start thinking about where BMS goes when you start thinking about buildings and infrastructure as platforms. Now, this is work by MIT Media Labs about responsive environments labs, this idea of this electronic nervous system and buildings that can act like an extension of what your needs are. They understand their performance and they can dynamically learn and change over time. This becomes a control panel for the future of buildings, not just to optimize the performance, the temperature, the light level in the buildings, but to actually start optimizing the experience and the performance from a programmatic perspective, connecting it to the individuals, to the actual people in the space and what their needs are. So we need to start thinking about what it means to design with an understanding of building information flows and with spatial conditions and occupant needs as states, moments, in a dynamic environment. We need to design conscious of the intersection of building performance, client program needs, and human comfort as that dynamic condition. Now, this starts to look a little bit like that Grasshopper definition I showed you before, this idea of being dynamic in the design process. We start being able to design these as the control systems for a building management system to create dynamic spaces. And each of these items represents a state and the various conditions driving between them. Another example of this from the Smart Geometry event back in London that we held in 2012 was this idea for a new opportunity for an architect and designer to start commissioning experience and to look at how we look at patterns in use in space and dynamically adjust these over time. What if a building management system could engage beyond just performance, but into optimizing program performance at the level of spaces and even desks live? But if this is truly going to be a learning system, it needs to move beyond states and relationships and rules that we give it. This starts needing to be auto-generated solutions via artificial intelligence, learning from occupant behavior into neural networks. By the way, this specific example of a neural network up here is actually an AI version of Super Mario navigating the Mushroom Kingdom on his own. With all of this, though, we also need to ensure that we're not just engaging in pure optimization, that we're instead moving to an informed and augmented agency, not just in design like I talked about earlier, but in experience. Informed and augmented agency and experience. It's the sort of thing that you have to continually ask yourself, and all of you will be asking yourself this more and more soon, and especially your children. You need to decide whether you're going to tell the robots what to do or they're going to tell you what to do. So it's good that Andrew's in the front row here, because just 2 days ago I had a conversation where we started talking about the term building OS. So I had other versions of this in mind as well, but I actually greatly appreciate it, so all credit to him. This starts making me ask the question of who writes and controls that building operating system? What kind of data can we provide to enable an embodied interaction? This sort of company is going to control how we interact with space. This is going to have a pretty strong impact on experience. And if we as architects are ultimately supposed to be creating the experiences of space, if we look back to our centuries as a profession of understanding all the social structures in life, how businesses operate, how governments operate, how people operate, how they interact with each other, and turning that into space, we should probably be involved in that. We should probably be in that conversation. And with that, can we start prototyping that building? Can we start prototyping that building and effectively write the API, the spatial API? Those are things that we can actually simulate through things like game engines. Games are perfectly suited to be able to have this malleable dynamic space as you move through. We can start moving beyond just pure VR to look at a static condition, to start programming the dynamic interactions that we have on space. Not just moving facades and stuff, but what does it mean from a security perspective? What does it mean from a program perspective if program's changing over time? What does it mean for us to simulate pulling our phone out of our pocket, interacting with the building to book a space and for it to tell me where I need to go to meet my meeting and to have the IT team show up with a projector? Those are all experiences that we can simulate in things like game engines. And that's the new method of prototyping that I really want us to start getting into. Now, here again is an existential crisis for our profession and even our industry. So, quote, key premise for the next decade, it's easier for software to enter other industries than it is for other industries to hire software people. Software and IT companies are moving into this territory rapidly. Sidewalk Labs, funded by Google, is working at urban scale to integrate buildings, spaces, and even digital experience for next generation urban environments. Companies like Intersection, which interestingly enough, I hired them about 15, almost 20 years ago to serve as an IT consultant for our architecture firm. So they were crawling under desks, plugging in workstations and installing AutoCAD for us. They have turned into a new company called Intersection that now works on the design of urban objects and how that's connected with the effort with what Sidewalk Labs is doing. They're materializing these things in space. In this specific example, these are some of the public Wi-Fi units in New York City. They replace those things that are public payphones. Anybody heard of a payphone before? They've basically removed the payphones and replaced them instead with Wi-Fi kiosks. What this means is these companies are our future. This is our future competition for the design of the built environment. All of us should be keeping an eye on these. It doesn't matter whether you're an architect or an engineer or contractor or whatever. These are the people that are going to be affecting it. They are going to have a bigger impact on how we experience space and the future of how we build space going forward. And if you're ignoring what they're doing, you're Kodak. And they have their reasons for moving into this area. They want to own the data. And I'm not kidding you, I did this 3 days ago. This is a screenshot from my computer. Why should we own our data? Nope, we think you mean why we should own your data. They're interested in how they monetize spaces now. It's not just monetizing what I do on my computer and my browser. It's not just monetizing my phone or my watch or the other things I interact with. It's the space itself. So we are deluding ourselves if we think everything is fine and the only digital battle we've got is over delivery standards or even digital geometry and formalism. We're deluding ourselves if we think the status quo of our industry's business models will last. So we tend to overestimate the effect on technology in the short run and underestimate the effect in the long run. And to quote Buckminster Fuller, we have to ask the question, do we want to go towards utopia or oblivion? It's time for us to start actually embracing data-driven design and data-driven experience and designing for that opportunity. We need to start thinking about what it means to design for digital natives. Now, perhaps it's cliche, but I have an almost 4-year-old daughter that's giving me completely new perspectives on how we learn and interact with our environment. And it's not just as simple as her walking up to my laptop and trying to touch the screen and move things around, but it's increasingly fundamentally different of how she expects to contact people, how she expects to talk with them and play with them. We need to start thinking about what it means to design for mobility and for change. Continents like Africa being almost entirely mobile-based, skipping mainframes, skipping workstations, pretty much skipping laptops and going straight to phones. I've kind of grown up with quite a few of those generations previously. I wasn't around during mainframes, but all the subsequent ones after that. We need to start designing for what is the network effect, for the graph of relationships between people, their interests, their things, and spaces. We need to design for the experience of metadata. We need to design cognizant of sensor networks in every part of our lives and how you can leverage that data stream at global levels and even at local levels, and design for adaptive environments that are rich with this information. We need to design understanding that our spaces are now augmented by computer vision sensing overlays that are invisible to us. We talk about this running hybrid models of geometry and analysis and design. Structural and mechanical, some of the engineering disciplines are quite good at that, of understanding both the analytic view of your designs, but also the geometric representation. We need to actually start thinking about modeling the immaterial aspects and dynamic aspects of spatial experience that are increasingly relevant. We need to start seeing like this being specifically the Google self-driving car. We need to start understanding these things that are, to our eyes, entirely immaterial, but actually make a pretty big impact on how we experience space. And really, in the end, we need to design understanding that we're ultimately redefining what we mean by space and place. Definition of space is no longer permanent, and our connection to a place, our interaction with others, and the meanings we assign to both of these are changing because of ubiquitous computing and through mobile devices and topics like ambient intelligence. Our approach to the digital and data in design and delivery for the built environment needs to stop looking like this. And it needs to start looking more like this. A new kind of sketching and prototyping of experience, a design of spatial interaction, and of networks. Now, if you want to help determine how design and experiential technologies will make a real impact on the built environment, start telling stories about these kinds of experiences. And don't be afraid if they start sounding a little bit like science fiction. The best kind of science fiction, just like architecture, enables us to ask critical questions about our social structures and propose the environment that will inhabit the future. Thank you.